Okay, so we're going into the section on trigonometry right now. Trigonometry is the study of the relationships between lengths and angles of triangles. Okay, so it's the relationship involving lengths and angles of triangles. And what we're going to be doing here is we're going to be initially talking about right triangle trigonometry. So in this first part, we're going to be dealing with right triangles. And as we get started here, I just want to kind of take a step back and kind of draw out a 30, 60, 90 right triangle. And this side of the x, 2x, and x root 3. Now if you think about it, this triangle can be any size, like depending on what the x is. The x can be 1, it could be 1,000. The relationship between the three sides is still always going to be x, x root 3, and 2x. And in particular, the ratio between two of those sides, let's say the opposite side x and the hypotenuse, the relationship is always going to be x over 2x, or 1/2. And that's basically what we're talking about here when we're talking about trigonometry. We're talking about the ratios of sides, comparing ratios of sides to each other. And so when I'm looking at the sine of an angle, that's going to be equal to, okay, like if I put myself here at this angle, it's going to be equal to the opposite side divided by c, which is the hypotenuse. Okay, and so for a particular angle, let's say 30 degrees, the sine of 30 is going to be equal to the ratio of the opposite side divided by the hypotenuse is going to be 1/2. So if I punch in sine of 30 into my calculator, I'm going to get 0.5 or 1/2. Now what they found is that, I can put in any angle here, let's say 33 degrees, and I'm still going to end up with a ratio of the opposite side to the hypotenuse staying the same always. It doesn't matter how big this triangle ends up being. If it's this big or if it extends this way and ends up being bigger, it's still going to be the ratio of this opposite side divided by the hypotenuse will stay the same. The cosine is just going to be the adjacent side, or the side next to where you are here, next to where the angle, divided by the hypotenuse. And the tangent is going to be the opposite side divided by the adjacent side. So what you're going to see a lot is you're going to see people write down the phrase Sohcahtoa. Sohcahtoa comes from, is basically a shortcut way of memorizing these relationships right here. So for example, the sine, the s is where the s comes from, is equal to the opposite side divided by the hypotenuse. That's where the o and the h comes from. So that's where so comes from. Ka comes from the cosine is equal to the adjacent side divided by the hypotenuse, and the tangent is equal to the opposite side divided by the adjacent side. So that's where Sohcahtoa, where you'll hear Sohcahtoa. Let's go down to actually this problem down here. So number 2 is talking about a rectangle, and ET is 26, so you have a right angle here. RT is 24. Now using, hopefully you can recognize that this is going to be a 5, 12, 13 triangle. This side's going to be 10 here. So it's asking for the sine of angle RET. So when you ask for the sine of an angle, you're looking for a ratio. Okay, so whenever I ask for the sine or the cosine or the tangent of an angle, my answer is going to be given in terms of a ratio. So RET, I'm going to put myself at that angle. So everything's going to be with respect to me sitting at this angle right here. And so like this would be the adjacent side with respect to that angle. This would be the opposite side with respect to the angle. The hypotenuse obviously will stay the same. So the opposite side is going to be 24 over the hypotenuse, which is 26, which can be reduced to 12 over 13. So the sine of angle RET is going to be 12 divided by 13. It's always going to be in that ratio. The opposite side to the hypotenuse is going to be in the ratio 12 divided by 13. The cosine is going to be the adjacent side, or 10 divided by 26, or 5 over 13. And the tangent is going to be the opposite side divided by the adjacent side, so it's going to be 12 over 5. Okay, so now let's talk about how we're going to use this to find sides. And this is where, I know that some of you are taking physics right now, this is where trigonometry can be very useful in solving certain types of problems. Okay, so let's actually start with B here. So I'm given an angle measure here, so I'm going to put myself here, and I'm looking for x, so that's the opposite side, and I'm given the hypotenuse, so I have to ask myself, okay, which trig function has the opposite side and the hypotenuse? And that would be, of course, the sine. So the sine of 18 degrees, that's the angle measure, is equal to the opposite side, which is x, divided by the hypotenuse, which is 12. And then I'm going to solve for x by cross multiplying. And so I get x equals 12 times the sine of 18 degrees. And I'm always going to write that number in front of the sine so that it's not mistaken for the sine of 18 times 12. Enter this into my calculator, and I believe I get 3.71. If you didn't get that, make sure you check on your calculator to make sure you are in degree mode, DEG mode. Okay, if you're not in degree mode, or if you're in like radian mode, which is RAD, you can often look at your calculator and you'll see an RAD on it, then you're in the wrong mode, and you need to switch to degree mode. Okay, let's go after this problem over here. Put myself at this angle right here. This is the adjacent side, this is the hypotenuse. Looks like I need to use the cosine. So the cosine of 50 is equal to x divided by 7. Again, x is equal to 7 times the cosine of 50. So x is equal to 4.50. If in doubt, round to the 100th place. That's house rule. Okay, so if in doubt, round to the 100th. The next one here is going to be, put yourself at this angle. So this is the adjacent side, this is the hypotenuse, so this will be cosine. So cosine of 62 is equal to 12 divided by x. So now this is a little bit tricky in that the x is in the denominator, so let's cross multiply. So I get x times the cosine of 62 equals 12. Now keep in mind that the cosine of 62 is just a number. Okay, it's going to be that ratio of the adjacent side to the hypotenuse when the angle is 62 degrees. So I'm just going to take that, both sides, and divide by the cosine of 62. Divide by that number. So x is going to be equal to 25.56. Okay, so now let's talk about this one right here. And let's talk about letter A. I am, in this case, looking for an angle measure. So this is going to be a little bit different here. Put myself there. opposite side, adjacent side, which means I'm looking at the tangent. The tangent of x degrees is equal to the opposite side, which is 5 divided by 8. Okay, so a little aside here. If I have 2x equals 8, what would you do to solve for x? Well, I'm multiplying here, so what I'm going to do is I'm going to do the inverse operation by dividing by 2, so x is equal to 4. Same thing if I had x squared equals 4. I'm squaring the x, so I need to do the inverse operation on the x, which is square rooting both sides. And what that in effect does is it kind of cancels out the squaring. So I'm going to get x, technically absolute value of x, is equal to 2. And that basically canceled it out. So what I'm going to do here, going back to the problem that we were doing here, is I'm going to take the inverse tangent of both sides. Inverse tangent. Okay, what in effect it does is it's sort of like when we're doing square root of x squared, it sort of cancels out the squaring. And so you're left with, on the left side, the tangent cancels out, inverse tangent kind of cancels out the tangent. I'm left with x is equal to the inverse tangent of 5 divided by 8. Now you got to look on your calculators, and there should be an inverse tangent button. It's usually above the tangent button. And so you do the inverse tangent and then type in 5 divided by 8 and then close the parentheses. And you should get x is equal to 32.01 degrees. So whenever I am looking for an angle measure, I'm going to always end up using the inverse trig function. Inverse tangent, inverse sine, inverse cosine. One of those three. Okay, that's the introduction. Let's go ahead and try some of the problems on the back side. Okay, I'm just going to kind of plow through some of the problems on the back side here, maybe all of them. And so for this first problem here, looking at a right triangle, hypotenuse of 52, acute angle is 37. Find the length of the shortest side of the triangle. The shortest side is always going to be opposite of the smallest angle, and hopefully you can see in this case that the smallest angle is going to be this one. This one's going to be 53 degrees right here, but I want to find x. So put myself at the angle, and from this angle's perspective, I'm looking at the opposite side divided by the hypotenuse, so it's going to be the sine of 37 is equal to x over 52, and just solve for x. X is going to be equal to 31.29. Number 4, cosine of angle K is equal to 5 over 7. So let's draw in a right triangle here. K is right here. Just let's make it so the adjacent side is going to be 5. This is going to be 7. And then I just need to do the Pythagorean Theorem. And when I do the Pythagorean Theorem, I'm going to end up with 2 root 6. I'm going to do the work for you here. 2 root 6. And then now, when I have all my sides there, put myself at angle K, because we're looking for the tangent of angle K. And so the tangent of angle K is going to be equal to the opposite side from angle K's perspective, 2 root 6 divided by the hypotenuse, which is 7. It's going to be a bunch of word problems here, and so first thing I'm going to expect you to do is do a drawing. So I'm going to demonstrate my awful drawing skills here. I apologize in advance. There's my boat. And there's my lighthouse. Okay, terrible lighthouse, but and it talks about something called an angle of elevation. Okay, so let's let's do a little pause here. If this is a horizontal line, the angle of elevation is going to be whatever the angle is coming off of the horizontal line in the upward direction usually. And then this would be what's called so this would be angle of elevation. This would be the angle of depression. Notice the angle always contains the horizontal line. I can't even emphasize this enough times, okay? Horizontal line is part of the angle of elevation or angle of depression. So in this case, here's my right triangle. Find the horizontal line, that's this one. And so it's going to be this angle right there is 5 degrees. The lighthouse has a height of 48. How far is the boat from shore? So we'll call that X right here. From this angle's perspective, put yourself at the angle. This is the opposite side. This is the adjacent side. So it's going to be a tangent of 5 degrees is equal to 48 divided by X. And then solve for X. So in this case, X will end up being equal to 548.64. Okay, next one here. Given a triangle, find angle A and angle B. So right away, I know that I'm going to use, because I'm looking for angles, inverse trig functions. Inverse trig functions, okay? So angle A, put yourself at this angle. It's the opposite side and the hypotenuse. So the sine of angle A is going to be equal to 14 divided by 30. Take the inverse sine of both sides. So A is going to be equal to the inverse sine of 14 divided by 30. Okay, and so you're going to end up with A being equal to 27.82. And then for angle B, you're looking at, this is the adjacent side, so angle B is going to be cosine of angle B is equal to 14 divided by 30, and then do inverse cosine of both sides. So B is going to be equal to the inverse cosine of 14 divided by 30. Plug that in your calculators. You should get a B angle measure of 62.18. Which matches up because these two angles should add up to 90 degrees. Okay. So now, number 7 here, it's missing some information. The child is 3 feet tall. So you got a child holding a kite, and the string is 250 feet long. The child is 3 feet tall. String makes an angle of 62 degrees with the horizontal. So here is the horizontal. This is called the angle of elevation, 62 degrees. And how high above the ground is the kite? So let's call this X. And don't forget that we need to add 3 after we find X. X is going to be the opposite side divided by the hypotenuse, so it's going to be the sine of 62 is equal to X over 250. And so X is going to end up being equal to, I believe, 220.74, and then you just need to add 3 to that. Okay, getting close to the end here. One diagonal of a rhombus makes an angle. Okay, so here's a rhombus. Keep in mind the reason we use rhombus a lot is because of the diagonals forming a right angle there, giving us a bunch of right triangles, and so that we can do some trig with it. One diagonal makes an angle of 27 degrees with the side, so this is going to be right there, 27 degrees. Each side length is 6.2. Find the length of each diagonal. Let's just find the length of one of them. So this is, well, let's call this x, let's call this y. So to find x, put yourself at 27 degrees. It's going to be the opposite side over the hypotenuse. Sine of 27 is equal to x over 6.2. Solve for x. X is 5.5. Double it to find the diagonal, and the diagonal will be 11.0. And then for the other one, it'll be cosine. So cosine of 27 is equal to y over 6.2. I'm sorry, this one ends up being 2.8, and the diagonal is 5.6. Sorry about that. Because when you solve for y here, you're actually going to get 5.5. And the diagonal will end up being 11. Sorry about that. All right, last problem here. Two buildings, 100 meters apart. Here's one building. Here's another building. Jackie Chan needs to get to the taller building, so here he is up here. Angle of elevation to the taller building is going to be 25 degrees. Here's the horizontal, it's 25 degrees. Angle of depression to the base of the taller building is 30, so there's 30 degrees right there. And the distance between is going to be 100, which means that this dotted line here is going to be, let's change the color, it's going to be 100. And I want to find x and I want to find y. So I have to use tangent. So tangent of 25 is going to be equal to x over 100. And the tangent of 30 is going to be equal to y over 100. Solve for x and y. So x is going to be equal to 46.6. Y is going to be equal to 57.7. And so together you're going to get 104.37 meters. And I think that's it. So that'll get you started. I just ran through a bunch of problems there just to make sure that you are familiar with how to use the trig functions. And go ahead and give it a try on your own now. Okay? Good luck.